Today we're going to be studying mathematics
and emerges from the second mirror.
These words sound
Be your teacher for today.
Hi friends, you're welcome to MSI EduTech Online Home Lesson. I believe that you are doing well. It's been a while. Today's class is going to be fantastic and so interesting. We thank you all for your support, your subscription to this channel. Remember, we are here to help you out. So without wasting time, today I'm going to take you through physics. And for those that are finding physics very difficult, and for those also that are preparing for external and internal examination, they are going to find it very easy through this class. So today I'll be taking you through AC circuit. AC circuit. What is AC circuit is all about? Don't get confused. AC is not talking about air conditioning. No, it's talking about alternating current circuit. Alternating current circuit. Now, before we go into that, I'm going to take you through AC circuit, and you need to complete this episode because this video is going to be divided into different episodes, and I believe that you will not miss any of these episodes, because if you do that, you might find it difficult by the time we start solving past questions on this topic, AC circuit. So let's roll it and see what AC circuit is all about. Now you need to understand that circuit is the connection of two or more components. The connection of two or more components. Let's take it for instance. We have resistor. Resistor is electronic component that oppose that oppose the flow of current in a circuit, and resistor can be connected either in series or in parallel. Series or parallel. So I'm going to take you through series and parallel. Now, if you have something like this, this is the symbol of resistor. You have something like this, resistor. This is R1, this is R2, R2. Another symbol for resistor is this. You have something like this, This is R1 and this is R2. Now this is what we call resistor in series. Now, how can we find the total resistor in series? RT will give you R1 plus R2. Remember, we can have more than two resistors in a circuit, but this is just an explanation on how to find your total resistance in series. So RT will give you R1 plus R2. Take note of this list. Now I want to show you another thing. Take a look at this. If you have a resistor like this, okay, then you have an alternating current flow through it, which is called voltage. This is R1, R2, and R3. Now I want to find the total resistance here, and take a look at this. Current flow through this, we call it I. In resistance in series, the same current flow through the circuit. Take a look at that. The same current flow through this circuit. The same thing happened here. high. The same current flow through this circuit because this circuit is connected in series. This circuit is connected in series, but different voltage flow through this circuit. Let's take a look at this. You have V1 and you have V2. You also have V3. So the same current flow through the circuit, that is resistance in series. The same current flow through, but different voltage. Now, if I want to find the total resistance in this circuit, RT will give me R1 plus R2 plus R3. I believe you are following this class. Now, I want to give you a very simple example how you can find the current flow through the circuit when resistors is given to you and you have your voltage here. So let's take a look at this and see how to find current that flow through the three resistors. Okay, let's take a look at this question. A question is example: find the current flow through the circuit below. And what is the circuit? You have something like this. Sorry, pardon me. Okay, another resistor. Then you have a voltage here, let's say 220 volts, and you have 2 ohms and 4 ohms. This is current. We want to find the current flow through this circuit. And remember, I told you earlier that the same current flow through series resistor but different voltage. So what are we going to do? Solution. The first thing you need to understand is you need to find the value of total resistance. RT equals to R1 plus R2. So RT is going to give us 2 ohms plus 4 ohms, which will give us what? 6 ohms. Okay class, I believe you understand this. Now the next thing for us to find out, please permit me to manage my board. The next thing to find out is we want to find the current that flows through this circuit. So remember, V equals to IR. V is voltage, I is current, which is always measured in amps, ampere. Then voltage V, and R, you can put RT here. RT is total resistance. So applying this formula, V equals to IRT. V is 220 volt. Put 220 volt here. I is current that we are looking for, and RT is 6. So we divide this by 6. Divide this by 6. Current will give us 220 all over 6. So this will give us 220 divided by 6. I will give us 36.6 amps. So this will be the current that flow through this circuit. Remember, the same current flow through the circuit. That is when you connect resistors in series. Now let me take you back to resistor in parallel. Now we are in resistor in parallel. In parallel, something different from series. Take a look at this. You have something like this. You have something like this. Okay. Now this is R1 and this is R2. We can also have R3 here, R1, R2, and R3. Now take a look at this circuit, something different from series connection. And what is that? The same voltage but different current. The current through I1, I2, and I3. Different current flow through these resistors because they are connected in parallel, but they have common voltage, which can also be called the same voltage. We can also have a parallel resistor connected like this. Take a look at this. You have something like this, something like this. Okay. This is point A, this is point B. This is R1, R2, and R3. Different current flow through this I2 and I3, but the same voltage flow through this circuit. I believe you can compare series connection of resistor and parallel connection of resistor. Now let me take you through this. To find the total resistor in parallel is a little bit different from series connection. Now take a look at this. Okay, let's take a look at this example. You have a resistor connected like this. Okay. Pardon me with my drawing. We have R1 and R2. I1, I2. Now to find the total resistance, 1 over RT equals to 1 over R1 plus 1 over R2. That makes it a little bit different from a series connection of resistor. But now, since we have two resistors connected in parallel, RT will give us R2 plus R1 divided by R1 times R2. You can only use this formula if you have two resistors connected in parallel. But if you have more than two resistors connected in parallel, you can make use of 1 over R2 equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus, until you get to the last one, 1 over Rn. Do you understand that? So this is parallel connection when it comes to resistor. Now let me take you through this question, and let's see how to find the total resistor, and not only that, how to find the current in each resistor. Okay. Now we want to find the total resistance and the current flow through each resistor. So what are we going to do? Let's start by finding the total resistance. 1 over R1, RT equals to 1 over R1 plus 1 over R2. Remember the formula I gave you or you used? RT equals to R1 plus R2 divided by R1 times R2. So if we do that, RT will give us 2 plus 4 divided by 2 times 4. RT will give us 2 plus 4 will give us 6. 2 times 4 will give us 8. We can call 2 here, 3, 2 here, 4. So RT will give us 3 all over 4 ohms. So that will be our total resistor. V will be I1 R1. V is voltage 12 equals to I1 times 2. 12 will give us 2 times I1. Divide this by 2, divide this by 2. I1 will give us 12 all over 2. I1 will give us 6 amps. Okay, now this is the current flow through 2 ohms resistor. Now let's check the the current flow through 4 ohms resistor. That will give us V equals to I2 times R2. From the circuit given to us, V is 12, I2 is not known, and R2 is 4. So this will give us 12 equals to 4I2. So you divide both sides by 4, divide this by 4, divide this by 4. I2 will give us 12 all over 4. I2 will give you what? 3 amps. Now, if you compare I2 with I1, you can agree with me that the higher the resistor, the lower will be the current, and the lower the resistor, the higher will be the current. Why? Because resistor opposes the free flow of current. It absorbs current in a circuit. Very much, I believe you enjoyed this class. This is first episode of AC circuit. Next class, I'll be taking you through capacitor circuit, and not only that, I'll be solving some past questions with you. Thank you very much. Until I see you next time, my name still remains the same, Mr. David. Au revoir.